Now we'll say a few things about static electricity. Remember what we said before about the structure of an atom. There's a nucleus with particles, and the nucleus is down in the center. And then around the nucleus are these regions that we call shells. And the electrons exist in these shells. And all that means is that they're more likely to be found at certain places. Some electrons are down in the innermost shell and others are in the other shells. The electrons that exist in the outer shell are not bound very tightly to the atom. And they can actually be easily removed off of the atom. And sometimes they come off of the atom. And one example of this would be what happens when you rub a plastic comb through your hair. When you comb your hair with a plastic comb, the friction from the combing causes some electrons to get scraped off of your hair and onto the comb. So the comb becomes negatively charged because it has these extra electrons on it. It still has the protons that it normally has, but it has excess electrons now stuck onto the comb. They tend to stick there. And your hair, because it has had electrons removed from it, your hair is then positively charged. And some of the results of this, your hair is attracted to the comb. You might have noticed this if you comb or brush your hair and you notice that your hair kind of pulls with it. That's a static electric charge. Force of attraction is present because one is positively charged and the other is negative. The comb is negative and your hair is positive, so they attract each other. Another result of that is that your hair tends to stand up. It doesn't lie flat. This effect is more apparent on different people than it is on others. Some people, if you have really fine hair, very thin hair, your hair will tend to stand up more easily. This happens, kids on a playground, for example. Here's a picture of my daughter coming down the slide, and the same thing is happening here. As she slides down the plastic slide, she is literally scraping, or electrons are literally getting rubbed off of her and her clothing and onto the slide. And the slide has become more negatively charged, and she has become positively charged. And you see the effects of that in the hair. All of the hairs are positively charged, and we said that like charges repel, so the hairs all repel each other, so they tend to stand out. They push away from each other, and the hair stands up. Now, one thing I want you to know is that a charge that builds up in this manner is done always, this always happens by the movement of electrons. If something becomes negatively charged, it is because electrons have moved onto it. If something becomes positively charged, it's because electrons have moved off of it. When some of the electrons get removed from something, it's left then with more protons than electrons remaining. So it becomes positively charged because electrons have been removed. So don't think this is the error. Don't think that something becomes negatively charged if it gets electrons and positively charged if it gets protons. Nothing gets extra protons. The protons don't move around. They're really stuck really tightly in the nucleus. So they stay put. It's electrons moving around that cause something to be negatively charged or positively charged. Something gets a negative charge if it has excess electrons, and a positive charge if it has a deficiency of electrons. And any charge that's built up in this manner is referred to as a static electric charge. And the term static simply means stationary or not moving. If you have electrons flowing, like electricity flowing through a wire, that's what we would call electric current, not static electricity. Electric current is the flow of electric charge, and a static charge stays put in one place. And static charges are commonly the result of friction. A couple of places where you see this in everyday life that you've probably experienced are clothing in the dryer. Sometimes when you take clothes out of the dryer, some tend to stick to others, and that's a static charge that's causing that. The rubbing together of different types of material has caused electrons to scrape off of one material and onto another, and so they tend to stick. And it can be a little bit annoying at times if you're trying to separate the clothes and get them folded. Another example is walking in rubber-soled shoes on a carpeted surface. You can rub electrons off of the carpet onto your shoes, and one result of that is that not just your shoes, but your entire body can become negatively charged. And then if you walk up to someone and touch them, then some of that charge jumps from you to them, and they feel a little bit of a shock. And it can be enough to really surprise someone at times. You can cause a little bit of pain from a static shock just from building up a static charge by rubbing your feet on the carpet. That little shock, that little static electric shock, when the electrons jump from one person to another, that's like a tiny, tiny, tiny little bolt of lightning in there, and that's why you can feel it. It's a little tiny bit of electric current for just a moment as the charge moves from one place to another. And it happens because a significant static charge was built up because of the friction.